Okay, so what is charge? Charge is a fundamental property of matter, like mass, like volume. So charge is something that a chunk of matter, a particle, either has or doesn't have. That's not quite as simple as you might think, because something that's neutral, like say me, I am loaded with protons and electrons. Protons are charged, electrons are charged, but my total charge is zero because, well, I've got an equal amount of positive charge to negative charge. Charge is measured in a unit that we call the Coulomb, after Charles-Augustin de Coulomb, a French physicist who came up with a law we'll talk about next video. So the Coulomb of charge is really big. If you look at the charge of an electron on your reference tables, it's a very small number, 1.60 times 10 to the minus 19 coulombs. And it turns out that this is the smallest charge that any given chunk of matter can have. We say that charge is quantized. We call this the elementary charge because nothing can have a smaller amount than that, and everything has to have a multiple of that. You can have an atom or molecule or person or horse or car with 5 elementary charges or 27 elementary charges or negative 14 elementary charges, but it can't have 2.7 or 1,000,000.1. It has to be an integer multiple of the elementary charge, 1.60 times 10 to the minus 19 coulombs. Now, this number was discovered by an American physicist named Robert Millikan at the University of Chicago, and this is how he did it. So here's a picture of his apparatus. It's a little hard to tell what's going on here, right? So here's what you've got. There's a little spritz bottle thing that we call an atomizer. There's a microscope where we can see things. There is a knob where we can control some voltage. So let's take a look on the inside. So here's a diagram. What you've got is a pair of parallel plates with a hole in the top of one of them. You spritz with the atomizer and droplets will fall in. Most of those droplets will just fall straight through, and some of them will actually get ejected back out the top. The vast majority never even make it inside the chamber, they just splatter on the top thing. But the ones that fall in the hole, once in a while, they'll start to fall in slow motion. And the reason why is because the atomizer charges them by friction and scrapes off some of their electrons. If you have a negatively charged plate on top and a positively charged plate on the bottom, and you have a negative particle in between, in addition to gravity pulling it down, there's an electrical force trying to push it up. And if those are balanced well enough, then you can get the thing to fall very slowly. If you then adjust the voltage just right, you can get them to hover. Then you can look in there with the microscope at the hovering droplet. You can measure its volume, calculate its mass because you know the density of the oil, and then you can from there determine how much force was necessary to keep it from falling. Doing a little bit of math we haven't gotten to yet, you can then determine from the voltage how much charge has to be on the droplet. If you do this, say, tens of thousands of times, you end up with tens of thousands of data points, and then in 1909, prior to the invention of the calculator, find the least common factor of those tens of thousands of data points. Et voila, you have the elementary charge 1.60 times 10 to the minus 19 coulombs. This Millikan's Oil Drop Experiment is a really important experiment, and those of you in AP Physics in particular should definitely make sure you know the details of it.